Hello and welcome. Operations research. Again, transportation problem. And now we are going to discuss about the degeneracy in transportation problem. Degeneracy faced while solving the transportation problem. As we know that when we get initial solution of a transportation problem by any of the methods out of northwest corner method, least cost method or Vogel's approximation method WAM, if the number of occupied cells are less than m plus n minus 1, that is number of columns plus number of rows minus 1, then the situation is called degeneracy. And when there is the situation of degeneracy, it is not possible us to write all the ui and vj values. Then what to do? Yes, we are going to get the answer of this question, what to do in case of the situation of degeneracy. This is a transportation problem and one of the clerks in the transportation company has suggested a transportation plan as follows. Some experienced person is there and he or she has suggested a plan that 30 units to be transported from plant 1 to market A, 10 units from plant 1 to market D, 20 units from plant 2 to market D, 20 units from plant 2 to market E, and so on. In this way, he or she has suggested total 7 different routes to transport 220 units. Now, as we can see that there are 4 markets and 4 plants, but the total demand of all 4 markets is 200 only, and the total supply available from the 4 plants is 220. So we have to create a dummy column of 5th market E, where we should transfer or allocate 20 units. And in this way, the transportation problem becomes a balanced transportation problem from the unbalanced one. Now, we need to check whether this, say, suggested solution is optimal or not. For that, we have to follow the UV method or MODI method. We have to calculate Dij values, etc. But to calculate Dij values, first we should have UI and Vj values. To have UI and Vj values, first we should check the RIM condition, whether the number of allocations are equivalent to or more than m plus n minus 1 or not. Here m plus n equals to 5 plus 4 minus 1 equals to 8. On the other hand, number of occupied cells equals to 7. 1, 2, 3, 4, 5, 6, 7. That means it is less than the RIM condition. The meaning of this is, if we go for checking the optimality of this solution as it is, we cannot have all the UI and Vj values. Some values of UI and or Vj may be missing. We cannot be able to write all the values because of this condition. This is called degeneracy. This situation is called degeneracy in solving the transportation problem. Now, if we cannot write all the UI and Vj values, we cannot calculate all the Dij values, then we cannot check the optimality, and ultimately we cannot arrive at the conclusion whether this or any other initial solution is optimal or not. And if it is not optimal, we cannot reach the optimal solution by the path of closed loop. So it is utmost necessary to have the number of occupied cells at least equivalent to this number. And as we can see, in this case they are not. So now the question is what to do under the situation of degeneracy. The only way is to have this much number of occupied cells. But here the reality is something different. Then how can we have this number of occupied cells when the actual number of occupied cells is less than this? The simple meaning is we should have the required number of occupied cells to be added to this number of occupied cells. This statement sound somewhat unusual. We can say that we should have one or more, that means in required number, the dimmed occupied cells. Now the thing is how to select this kind of cells. First of all, out of all the empty cells, we have to select one or more required number of cells to be treated as dimmed occupied cells. Now let's discuss the technique of that thing. The technique is to select one empty cell which is independent and then treat that cell as occupied cell. Let's do everything on board and on paper. First of all, which are the empty cells? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Because total there are 5 into 4, 20 cells, out of which 7 are occupied, so remaining 13 are empty cells. Now let's identify these 30 cells. 1B, the cost is 4. 1C, the cost is 9. 1E, the cost is 0. 2A, the cost is 20. 2B, the cost is 6. 2C, the cost is 11. 3A, the cost is 7. 3B, the cost is 1. 3D, the cost is 14. 3E, the cost is 0. 4C, the cost is 12. 4D, the cost is 6. And 4E, the cost is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 empty cells and 7 occupied cells. The total is 20, and yes, we have 20 cells, 5 columns into 4 rows. Now, out of these empty cells, we have to select, in this case, one cell, because we have already 7 occupied cells and the minimum number of occupied cells we need is 8. So we just require to select only one empty cell to be treated as dimmed occupied cell. Which one? The rule is to select independent empty cell. Now what do we mean by independent empty cell? If we refer to reference book, if we go through lectures and seminars of some seniors, they always pick this statement: select independent empty cell and put the sign of epsilon into it to treat it as an occupied cell. But what do we mean by this word independent? The meaning of the word independent is the cell we select should be such that from where we cannot trace a closed loop. Yes, the empty cell we select such that from where we cannot start the closed loop. Yes? Okay. Now let's check all these 13. If we want to start a closed loop from 1B, is it possible? If we start the closed loop from 1B, a very easy route is available to have a closed loop, to draw a closed loop. That means 1B is not independent, because from that cell we can easily trace a closed loop. So it doesn't qualify. 1C, if we start closed loop from here, either we have to go here or we have to go there. If we start in clockwise, first turn, second turn, third turn, that's all. First turn, second turn, that's all. First turn, second turn, third turn, that's all. That means from this cell we cannot trace a closed loop. So this cell qualifies. 1C qualifies. Yes, this is independent. When we solve this kind of problem, we have to check all the empty cells for this purpose. It is not as easy as to write a sentence that select the independent cell. As a student, if I think as a student, it is a time consuming job. We have to consume required time for this every time we face a degenerate solution. Okay, 1E. Can we draw a closed loop? Yes, easily. So this doesn't qualify. 2A. Can we draw a closed loop? 1, 2, 3, 4. Yes. So 2A doesn't qualify. 2B. Can we draw a closed loop from 2B? 1, 2, 3. No. 1, 2, 3, 4, 5. No. We cannot reach here again. Which one is that? 2B. Again, let's check again. Is it possible to come again here? Yes, it is possible. 1, 2, 3, 4, 5 and 6. Yes, closed loop is possible from 2B, so it doesn't qualify. 1C. Can we? From 1C? Yes. 1, 2, 3, 4, 5. No. 1C. Can we? No. From 1C we can't. So it is independent. 3A. Yes, 3A. Can we draw a closed loop from 3A? Is it possible? 1, 2, that's all. 1, 2, 3, 4. No, we cannot draw a closed loop from 3A. So it is also independent. 3B, is it possible? 1, 2, 3, 4, 5. But we can't reach here because we cannot draw a closed loop with diagonal line. No, it can be. Let's try again. 1, 2, 3, 4, 5, 6. No, we cannot reach again here. So 3B is also independent. What about 3C? 3C is occupied. What about 3D? Let's check. 3D. Is it possible to draw? 1, 2, no. 1, 2, 3, 4, no. We cannot reach again here. So it is also independent. What about 3E? Can we draw? 1, 2, 3, 4, 5, 6. But still, if this cell is occupied, then only we can complete the closed loop. So 3E is also independent. 3E. What about 4C? Can we draw closed loop from 4C? 1, 2, 3, 4. Okay. Over. This is the critical cell. From there, it is not possible to take turn on this side, and hence the closed loop cannot be drawn from 3C. So 3C is also independent. 4C. What about 4D? Can we draw? Yes, easily. 1, 2, 3 and 4. We can draw a closed loop from 4D. So that cell doesn't qualify. And now 4E. If we start drawing closed loop from here, can we? 1, 2, 3, 4, 5 and 6. Yes, we can draw. So 4E also cannot qualify. So out of 13, we have 1, 2, 3, 4, 5, 6 and 7 independent cells from where we cannot create a closed loop. We can select any one out of these 7. Now the question is which? Which cell should we select to treat it as an occupied cell? Or which cell should be selected as deemed occupied cell? The advice from our seniors is to select the independent empty cell with the least cost. Yes. In this case, cost is 9, 11, 7, 1, 14, 0 and 12. Obviously, the least is 0. So we are going to select 3E as if it is occupied. And we substitute, or rather we are going to follow the tradition of writing epsilon, the sign epsilon into that. Epsilon is the lowest possible quantity of allocation. It is actually believing that this cell is occupied. Because according to our aim of minimizing the cost, if we go for allocation out of these cells, the first condition is it must be an independent cell. So we selected 7 independent cells. Now if we have to allocate some quantity to any of these 7 cells, obviously we ought to select the cell with the least cost. That's why we have to select the independent cell with 0 cost. Yes. Even if it falls in the dummy column or row, it equally qualifies to be selected. Yes. Now we have 1, 2, 3, 4, 5, 6, 7, 8 occupied cells, and yes, we have 8 occupied cells. So now the condition of m plus n minus 1 occupied number of cells is satisfied. That means now we can have all the ui and vj values. Now before going forward, I want to give you an assignment. Write this case separately in your rough notebook or in your rough page, and don't go for this process, and just try to write ui and vj values having only 7 occupied cells, and see what happens to you. This is your assignment. Now let's move forward, and let's first of all determine all the ui and vj values. I'm very sorry, in a hurry I started to rub it, but first of all now we are going to substitute, rather determine all ui and vj values. And as we know that any one of ui or vj values we can take as 0. We have all rows with 2 allocations, and we have no other row or column with 3 allocations. So let's select u1 and take its value as 0. And we know that Cij equals to ui plus vj. Therefore, ui equals to Cij minus vj, and Vj equals to Cij minus Ui. So according to this formula, we can have these two values. V1 can be 6 minus 0, 6, and V4 can be 1 minus 0, 1. V4, sorry. Now on the basis of these two and relevant occupied cells, we can have two more Ui values, 6 and this occupied cell, 4a. C minus V, 7 minus 6, that will be U1. This is U4. And similarly, on the basis of these two, we can have U2. C3 minus V1, so U comes to 2, that is U2. On the basis of this value of U and this occupied cell, we can have Vj value in this cell, that is V5. C minus U, 0 minus 2, minus 2 will be the value of V5. Now on the basis of this V value and this occupied, any other occupied cell, can we go for another thing? Is it? Yes. 0 minus minus 2, that will be positive 2. Value of U3, value of U3 positive 2, is it? Yes. Then how can we arrive at these two values? Yes, on the basis of these two U values, we can have these two V values. 0 minus 2, so this value of V will be minus 2, it is V3. And similarly, 1 minus 1, C minus U, 1 minus 1, this value of V is 0, that is V2. In this way, we have all Ui and Vj values. Now only we can calculate Dij values for all empty cells except this